Okay, let's go through lessons 3.2 and 3.3 and 3.4. All right, so that you you have this available to you. In lesson 3.2, we talked about prime and composite numbers. Okay, what's a prime number again, Tyler?
A number that only has two factors.
Two factors, one in itself. Okay, what does that mean? Two factors, one in itself. Matt.
It means nothing can go into it, just itself and one.
Yeah, exactly. No other numbers can go into it other than the number listed and 1. So if that's the case, then that number is called prime. Okay? What about the number 1? Is that prime? Raiden?
It's neither.
It's neither. Why?
Because one doesn't have one in itself.
It doesn't have
two factors.
Doesn't have two factors. Prime numbers have two factors. They have to have two factors. If it's not prime and it's not neither, then it's called a what? A composite number. And so then it has many factors. It has more than two factors. For example, the number 10. How do you find those factors? What's a good way to find the factors? Start with 1 and then do what, Josh? What two factors can you always find for a composite number?
One in itself.
One in itself. And then go through the divisibility rules. Like, is it even? Then 2 is a factor. 2 times what? 2 times 5 in this case, okay? Or the number 32. 1 and 32, 2 and 16, 4 and 8, and then there's nothing in the middle, so now you know you have them all. Okay? So anytime you need to list all the factors, start with the outside numbers and work your way in. Alright? Then, I gave you a list of the the perfect squares. Matt. The perfect squares are important to kind of know what those are, especially the ones like 25 and 49 and 121. What do all those have in common? What are those numbers, the ones I listed? 4, 9, 25, 49, 121. The next one would be 169. What do they all have in common? Johnny?
They're all perfect squares.
They're all perfect squares, and
they're the square of a prime number.
they're the square of a prime number, which means they have only 3 factors. 1 itself, and then the prime number that makes that. Okay? So 1 and 4 and 2. 1 and 9 and 3. 1 and 25 and 5. 1 and 49 and 7. 1 and 121 and 11. Does that make sense? So that's something cool about prime, so perfect squares of prime numbers. Then we went on to lesson 3.3, which talked about prime factorization. And that's kind of like writing the formula for a number using only prime numbers. So if you're given a number like 165, you can find the prime factorization. You can find the formula by doing something called a factor tree. So finding a number that goes into the given number, then divide and write the two numbers that make this number. Now if the number is prime, you stop. If it's composite, you keep going. And find the factors that go into that number. Once you have all prime numbers listed, then you can use those to write the formula. and to write the numbers in numerical order. 3 times 5 times 11, these prime numbers make the number 165. Okay? So, again, you start with a number, find two numbers that go into it. It doesn't matter what two numbers, you can use 2 if it's an even number, and then find the number that goes with 2 to make the number. Okay? So if we were to factor 180, it's 10 and 18, and then 10 is made with 2 and 5, and 18 is made with 2 and 9, and then 9 is made with 3 and 3. So these are all the prime factors. I circled all the prime factors. And then if there's 2 2's in the formula, then you use an exponent. So it'll be 2 to the second power. And there's 2 3's in the formula, so we use 3 to the second power. And there's a 5 in the formula. So this is how you'd write that. Okay? Any questions on this? So then in 3-4, we're using that process to find the lowest common multiple. That's what we did for today. So there's 2 ways to find the lowest common multiples. One is to write the multiples of a number by just continuing to add the same number over and over again, or multiply. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, and so on. And then do the same thing for the other number, and then circle the lowest one that they have in common. That's the lowest common multiple. Make sense? Sometimes the product of the two numbers is the lowest common multiple. So 4 times 10 is 40. So that is a common multiple, but is that the lowest common multiple? No. Nope, it's not always the lowest common multiple when you multiply the two numbers. When would it always be? Do you know when it would always be the lowest common multiple? Two prime numbers, like 5 and 7. The lowest common multiple would be 35, right? Or 2 and 13. Lowest common multiple would be they're two prime numbers, so multiply them together. 2 times 13. Tyler. Good, thank you. Thank you for participating. 26. So if you have two prime numbers, you can find the lowest common multiple by multiplying the two together. Okay? There's also an advanced method to find the lowest common multiple. It's to factor or find the prime factorization of each number, then multiply the greatest power of each of the prime factors. So that means that for 4, you make 4 with 2 squared, and you make 10 with 2 times 5. So we have to use 2's in the formula and a 5. 2 squared is the biggest power of the 2's. So we use 2 squared, which is 4, and 5. 4 times 5 is 20. Okay? And then we did this example together. Let's see, we did some other examples. Let's see here. Oh, no, I erased them already. Well, we did those for your assignment today. So, any questions on what we've done so far in this chapter? Prime and composite, prime factorization, greatest common factor, or sorry, lowest common multiple. All right.